frequency distribution tables don't always do a great job of organizing your data. This is going to happen especially where you have data sets, like I've got one here, where you have a lot of different values. Now, I could have a large data set with not too many different values, like if I had, let's see, 8, 8, 8, 6, 4, 3, 7, 8, 6, 5. If I have something like this, and this kept going on and on and on, but using the same small set of numbers, somewhere between 3 and 8, then that's easy. All that I have to do is create a scale on the side that just covers that range of values from 3, 4, 5, 6, 7, 8. And then I can have frequencies on the side that are really large. I could have 23s and 18 4s and so on. I could have a really large data set, but as long as I don't have too many different numbers in my data set, I can have a nice small table with only so many categories on the side. Here I've only got, 6 different categories on the side. The reason that that's nice is it means that even for a really large data set, I can take the whole thing in at a glance. So that's really what we want in a table. We want to be able to convey information to another person. We want to be able to take raw data and turn it into a table that helps another person quickly digest the data, quickly see what's happening with the data. But if you have, like I've got here, a data set where there's a lot of different values, some of them probably don't repeat. I don't even know if there's any repeating values in here. You're going to end up with a really large table, and that kind of defeats the purpose. Let me create a bit of space here, and then I'll show you what I mean. Now, if I was going to make a table out of this, the same way that I've already showed you how to make a frequency distribution table, what you want to do is you want to find your lowest and your highest score. So now the lowest score in this data set is the 28. And the scores here, the highest, it goes up to 67. So what that would mean is that I need a table that is going to run from 67, and if I want to have individual scores listed, I have to go 66, 65, and so on, all the way down through the 50s, and down through the 40s, and so on, all the way down to finally 28. There's going to be a total of 39 different categories here. Now, because remember, we need to keep a place for each of the empty, or we need to show empty categories. What I mean by that is, I know, for example, that there is a 67. There's actually one and only one 67. But is there a 66? No, I don't think so. If you go through the data set, I think the next number in the 60s going down is 64. So we're going to have a 0 and a 0, and then when I get to 64, then there'll be another value. But mostly what you'll end up seeing is that we have lots and lots of empty categories, and occasionally there'll be a single frequency of a score showing up. And again, this will be a huge table. It's going to be 39 different values long in this case, and this isn't even really that large of a data set. If I was doing a sample of something like how much each customer at a cell phone company spent in the last month on their cell phone bill, I could have thousands of different values, none of them being repeated values. So I might have to have a table that has thousands of categories. That would be of no real use to me. You might as well just look at the raw data. Your table is not going to help you to quickly digest what's going on. So this is where we need to start grouping our categories. We can't just have a spot for 67 and a spot for 66 and a spot for 65 and so on. We just need to have a category that looks more along the lines of something like 60 to 70. And then down here we're going to have 50 to 60 and so on. Now we do need to worry about overlap, so we can't exactly have 50 to 60. We would have to have our categories work more like this. 61 to 70, and this would be 51 to 60. And so a 60 would actually go here and not up there. But we could group the values together. There's going to be 10 in each category, and so we could cover a lot more of the data very quickly. And for a data set like this, you can see that we only have to get down to 28, and so we're really just going to have a few categories. But how do you decide what to make the category? Should it have been 60 to 70 like I started off, or is it better to do 61 to 70? What's the right way to set these up? Well, there is a series of steps that are what you would call guidelines. They're not hard rules. If you break these rules, it's not a big deal, but they're meant to make it easier for you to get to a table that is nice and easy to organize the data into, and it's small enough to digest the information. So what does that mean? Small enough. Well, ideally, actually let me change colors here. Ideally what we want is around 10 categories. Categories are what I'm showing you here, from 61 to 70. That could have been from 60 to 65, it could have been from 62 to 68, whatever it ends up being, just that range that we express here, that's our category. They're also called, at different parts of your text, class intervals. And I suspect they might also just call them classes. All of these mean the same thing. They're the category, the grouped frequencies that you see just in one of the rows here. So we want around 10 of them. Why do we want 10? Well, like I said, we want a table that we can quickly take in. We don't want to see 15, 20, or 30 rows in a table. That's just a bit too difficult to try and make sense of the data. That's not much better, like I said, than just looking at the raw data. I think that there's only 25 values in here to begin with. So why would you want to have more information in your table than you had in the original data set? Your data set's supposed to make things a bit more compact and easy to look at. So we want to have about 10. That's about the most we want it to be. It doesn't matter if you end up going up to about 11 or 12, but I wouldn't go much higher than 10. And I'll show you how to control that soon. You also don't want to have much less than 10 because, well, have a look at a table that takes that idea to the extreme. Let's say I only wanted to have 2 categories. So I could make my data from 30 to 60, or actually let's make that 31 to 60. Oh, and that wouldn't be large enough actually. Let's make that 35 to 70. And then I would do 0 to 34. Okay, so this should cover everything. Remember, my largest number was a 67, my smallest number is a 28. And so I would have just 2 categories, and without going through this and working through it properly, I'm sure that the majority of them are going to be somewhere in 35 to 70, so it could look something like this. It could be that 22 of my values sit here, and the remaining 3 values sit in this range. Does this table really tell me about how the data is distributed? Not really. It condenses it so much that there's not really anything to look at here. I might as well have just said values that are between 0 and 70, I have a frequency of 25 of them. And this really tells me nothing at all. It just tells me where all of my values are. It doesn't give me a breakdown as to exactly where they sit. It would be better to see how many buses had 60-something passengers, how many buses had 50-something passengers, or passengers in the 40s or in the 30s. That would be a better look at breaking down the data. So we want to have about 10, not too few, not too many more, and so this is what we're going to be working towards. Now, I said that there's guidelines for achieving this. This is sort of the goal that the guidelines are working towards. And so if at any point the guidelines are not helping you get to this goal, you can dismiss them. So what do I mean by these guidelines? Well, let's break them down. I'm going to erase this as well. Just remember, we want to have about 10 categories. I'm going to do this in steps. Okay, so the first step is going to be to find the range. Find the range of your data that's been presented in your raw data. Well, a range, this is going to be presented as a proper formula later in your course. I think in chapter 3. No, chapter 4. The range looks like this. It is your maximum score minus your minimum score. So in our case, that is a 67 minus a 28, and that comes out to be 39. So between the smallest amount of passengers on the bus, which was 28, so the least packed bus, to the most packed bus, 67, there was a difference of 39 passengers. So this is the range of all of the values. We need to cover from 28 to 67, which is a range of 39 different values. So this is what we have to start off with. Step 1, we find the range. Pretty simple. Step 2, you're going to divide the range by your desired number of categories. Now I said that the desired number of categories is 10. That might change under some circumstances. Maybe you only have a really small space for a table, so you need to have less categories. So you might only want 5 categories. Or maybe you need a more in-depth look at exactly where the data falls, so you might not want only 10, you might want 15 or even 20 categories. It really can change depending on what your needs are, but for your course, the rule of thumb is we're looking for 10. So divide the range by 10. So the range divided by 10 is equals to 39 divided by 10, and so this is 3.9. Great. So 3.9. What do we do with this? Well, what we're trying to do here is we're trying to determine just how wide each one of our categories should be. So when I'm setting up my table, these are going to be the categories along the side here. If I had, let's say, something that looked like this, from 61 to 70 as being my highest category, and so then below that would be 51 to 60, and so on. These are categories that have a width of 10, because if you count these up, they include the numbers 61, 62, 63, 64. Sorry, this might seem kind of simplistic, but I just want you to really see this. 68, 69, 70. Okay, so count these numbers. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This, even though it doesn't go from 60 to 70, this covers 10 possible values. So this would be a category with a width of 10. So right now, this is our category width. And it's not a very nice one. 3.9 means that wherever our lower end of our category, whatever the bottom number is in our category, let's say we have a category that starts at 10, this is telling us that the top of the category should be 3.9 higher. So this would be from 10 to 13.9, which is a really awkward sort of category. And it's not the sort of thing that really works with the idea that we want our table to be something that's easy to glance at and quickly digest. So even though we might get a number like 3.9 out of the mathematics here when we divide the range by 10, we're not going to stick with this number. This is where the next step comes in. So step 3 suggests this. And remember, these are all just suggestions. So if you want to get rid of one of these at any point, that's fine. We're just trying to work towards a small table with enough categories to break things down a little bit, or to break them into different groups a little bit. Take your 3.9 and round the category width. And I use the word round sort of loosely, round the category width to an easy number to work with. Okay, so what does that mean? It means don't just round 3.9 up to 4. Normally you would just round a number like this up to 4. 4 isn't necessarily the easiest number to work with. 5 is an easier number. It's easy to count by 5s. 5, 10, 15, 20, 25, 30. Anybody who's looking at a table that's broken up into groups of 5 would sort of immediately get a sense as to what's going on with the data. Maybe not so much if I was to round this to 4. So when I say rounded, I don't really mean it rounded. I just mean find a nice easy number to work with that's nearby to 3.9 and go with that. So easy numbers that are nearby, or easy numbers to build a table out of, would be things like 2, 5, 10, 20. If your numbers are huge, you might want to be counting in the hundreds and so on. Just go with really simple numbers to do math with. 50 would be another one that would work out. Okay, so having said that, if you chose to go with 4 instead of going with 5, like I'm going to here, I'm going to say 3.9 is going to become 5. This will be my new category width. If you chose to go with 4, you would not be wrong. I just find it's easier to go with a number like 5. So 5 is my new category width. So that's my third step. So what am I going to do with that? Well, now it's time to start building my categories. And your textbook gives some suggestions as to how to do this. I want to show you exactly what you should do at this point. Take multiples of your category width, every multiple of your category width, starting with 0. So 0 times 5 is how much? 0 times 5 is equals to 0. 1 times 5 is equals to 5, and so on. 2 times 5 is going to be equals to 10, and then 15, and then 20, and so on. So you keep going. Now, these are going to be the bottom number of your category. So if I had a category that went from 10 to 14, 10 would be the bottom, 14 would be the top number. These are going to be all the bottom numbers. And so my bottom numbers, actually, I keep forgetting, you guys count down. You put your low numbers at the bottom. Let me, well, I'm going to stick with it like this for now. You'll see. Okay, so we're going to keep going with this. 25, 30, 35, 40, 45, 50, all the way up until we get to 65. And why 65? Well, remember, our data had a maximum value equals to 67. I don't need to have categories that are going to include numbers that are larger than 67, 70, thereabouts. So I'm going to stop when I get to 65. And remember, this is the bottom of my category. Each one of these is going to have a width of 5. So not only am I doing multiples of 5 to get the bottom, the width is also going to be 5. So 5 numbers starting at 0 is going to be 0, 1, 2, 3, 4, and that's it. This is 1, 2, 3, 4, 5 numbers. So from 0 to 4 is my very lowest category. And then here's where it picks up. After the 4, I get to 5 is in the next category, 5 to 9, and then 10 to 14, and so on. 15 to 19, 20 to 24, 25 to 29, and so on and so on and so on, until I get up to 65, 66, 67, 68, 69. That is my last set of 5 numbers. Why 5? Because 5 is the number that I got there. Why am I starting with 0, 5, 10, 15? Because those are all multiples of 5. Now my lowest number, my minimum, was equals to, I believe, 28 or thereabouts. It was either, yeah, I think it was 28. So I don't need to have any of these, lower categories here. I really just need to start with 25 to 29, that's going to be the lowest one, and work by 5s up to 65 to 69. So when I actually create my table, which I'm about to do now, it's going to look like this. I'll have my categories, and I'm going to do 65 to 69. The next lowest down will carry me up to 64. It's going to be 60 to 64. Every one of these beginning ones, every one of these bottom numbers is going to be a multiple of 5. So the next one down would be 55. The next one down would be 50, 45, 40, 35, 30, and 25. Okay, so 55 goes up to just the number right below the next category, so that's 59. 50 goes up to 54, which is the number right before 55. 45, to 49. 40 to 44. 35 to 39. 30 to 34. 25 to 29. So this is my table. Those are my categories. Now I can start to put in my frequencies. And so to do that, I'm going to grab this table and I'm going to take it, this all the way up. Actually, I need to make a spot to put all of the original data because I've got to be able to see it to figure out what the frequencies are. So give me just a second to do that, and then we can get to work on filling out the table. All right, so I've got the data here now. So let's actually get rid of this. And I'm going to put in a column where I just do a tally, and then I will get to my frequencies. Okay, so what I mean by a tally, that's when I go through my values like 50 and I check right next to the 50s. Let's actually make some lines so this is a bit easier to see. Okay, so next to the 50s, I'm going to have a tally mark there. So I've dealt with the 50. And then I'm going to go to the next number, 39. So 39, where does that happen? That's right there. And then 46. 46 is right there. I'm doing this so that I can systematically go through my data and make sure that I don't miss a single thing. So 55, that happens right here. 28. There it is. 38. 38 goes here. 50 is here. 47. It's there. 39. 61. 67. There we go. 37 is here. 58. So already we're starting to get a picture here. We can see that there's a clustering towards the low end. 59 to 59. 33 goes in here. 44 right there. 55. 64. 53. 58. 44. And 50, 41, 52, and 39. Okay, so maybe not so much closer towards there. It actually looks like it's pretty evenly spread out between 35 and 59, and then it tapers off a bit towards the high and the low extremes. But the reason, again, for the tally was to make sure that I go through systematically, and then I can list my frequencies fairly simply. So my frequency in the 65 to 69 category or class interval is just 1. I have 2 values that fall between 60 and 64. I have 5 values that fall between 55 and 59. I have another 5 values that are between 50 and 54. 2 values here, 3 values here. 5 values again sit between 35 and 39, and then only 1 in each of the lowest categories there. Okay, so we can do a quick check here to make sure that nothing has gone wrong, and the simplest way to do that is to calculate your sample size using the sum of your frequencies. So 1 plus 2 makes 8, and then we have another 5 and 5. That brings me up to 18, 19, 20. This is another 8, and there's 2. That makes 30. I didn't think I actually had that many of these. Let's count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so yes, I've definitely done something wrong there. I've got a few too many values. Did I add that right? Let's see, 3, and that's 13. Oh, wait, sorry. 3. Oh, I see, okay. 3 and 10 makes 13. 15, 18, 19, 20, 25. Sorry, I added that wrong. So that is our table completed. Now we don't need the tally part to get full marks for a table. You really just need your categories, like I've got here, and your frequencies that go along with those categories. So we've got that. We've also gone back through the data. We've double checked that we included all of our values. Maybe one thing you might have noticed here is that I had said that the ideal number of categories was equals to 10, and we even did our range divided by 10 in order to get our width. Now we had to do a little bit of rounding there, where we changed our result because we didn't really like the 3.9. But the whole idea was we were shooting for 10 categories. And look at what we have here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9. We don't actually have 10. Now, why do we only have 9 and not 10? Well, it was because we didn't take our 3.9 that came from the math. We got rid of that, and we went with a 5. If you make your widths of each category larger, you're going to need less of them to include all of the data. Is that a problem? We didn't get 10 categories instead of what we did get, we got 9? No. This is just an ideal. It doesn't matter if you don't get 10. 8 would have been fine, 7 would have been fine. We could have had 11 or 12 categories. These are just basic guidelines. You just don't want to end up with what I would have had if I had not grouped anything at all. I would have had 39 different categories if I had just gone with keeping the data as individual values. So that would have been no good. So we did get close to our idealized value of 10. So don't worry too much about that. We did it in a way that made sense. We created categories that had widths of 5. Remember, you want to stick with widths that are nice and easy to work with. Things like 5, 10, 20, 50, 100, and so on. Something you can do the math in your head quickly with. And so that's it. This is about the largest amount of data I would think you would expect to see on a test. But you would definitely have to do this sort of a process on a test, especially on an assignment if your class has assignments. And remember to make use of this tally column, even though you won't get marks for it. Make use of the tally column because it helps you to avoid making simple mistakes, forgetting data, or double counting data.